In the last few videos, we've looked at how to add, subtract, and multiply complex numbers. It would make sense to look at division next, but before we divide, we have to talk about a new concept, that of complex conjugates. So we know complex numbers are made up of a real and an imaginary part. Imaginary numbers are very hard to work with. We can't really visualize what they represent because they're not real numbers. And we live in a very real world. So to help us process things that have imaginary numbers, it's useful to find out a way of turning the imaginary into the real. And we do that by using complex conjugates. Now, complex conjugates, despite its complex name, are actually fairly straightforward. If I give you a number, a plus bi, the conjugate is a minus bi. So all we do is we change the sign of the imaginary part. If I have 5 plus 2i, the conjugate is 5 minus 2i. If I have 3 minus 4i, take a moment, pause the video, and predict what the conjugate of 3 minus 4i would become. Now, hopefully you've realized that the 3 will stay the same, but this negative sign will turn positive. And so the conjugate of 3 minus 4i is 3 plus 4i. So this is a very simple relationship, and conjugates work both ways. So if we start with a minus bi, the conjugate is a plus bi. So all of these we call conjugate pairs because they have the same real part, and the imaginary part differs only by a negative sign. And the reason we like these is because there's a special relationship that happens when we add or multiply these. So if I add these two numbers together, we'll combine our like terms. So 5 and 5 is 10, but then plus 2i and minus 2i cancel out. So we have 10 plus 0i. We don't really care for 0i. So the answer is just 10. So by adding the complex number and its complex conjugate, we have turned the imaginary number into a real number. And this also works if we multiply. So let's say we start with the same two numbers, 5 plus 2i and 5 minus 2i. Now over here, I'm going to write out my box. 5 plus 2i, 5 minus 2i. 5 times 5 is 25. 5 times 2i is positive 10i. Then we have negative 10i and negative 4i squared. But remember, I squared turns into negative 1. So that whole box just turns into a positive 4. And I notice you can't quite see down there. So I'll write it up here, positive 4. So if we combine all of our like terms, we have 25 plus 4 equals 29. And then we have 10i minus 10i, which is equal to 0. So once again, we find everything cancels except the real part. So we've now shown that when we add or multiply a complex number and its conjugate, we always get a real number.